Setting up meeting for YouTube Live. Got another blank screen. Setting up meeting for YouTube Live. Good, I think I've turned the sound off there, so we should be live. Shrink that screen down.
Yes, I am seeing live image, David, although I've got the sound turned off for it. So it looks like you're good to go.
Okay, so welcome, folks. This is our third session of live streaming. Hopefully we are live on YouTube at the moment. This is a live image of the moon. Unfortunately, it looks rather hazy. I'm going to turn up. But we've got some lunar craters there. Let me explain. I will show a picture of the telescope that's providing this image, but I am controlling it through an iPad. And I am slowing, you can't see me pressing these little buttons, but you can see 4 little arrows there. And I'm going to start at the bottom end of the moon. Now, in our telescopes, we have inverted views. So let me just pop this out a bit. In our telescopes, we have south at the top. So we're starting at the north end of the lunar surface. So this will be the top of the moon as you see it with the naked eye. And what we can see here is a very dark crater. This is the crater Plato, about 60 miles in diameter, this one here. And that sits on the sea, the Mare Imbrium, the Sea of Shadows. Running off to the south is a little chain of mountains. These are our lunar Alps, obviously named after the earthen Alps, but you can see a little gash right through the Alps. This is the mysterious Great Alpine Valley, about 170 kilometers long, about 20 kilometers wide. Now, unfortunately, the seeing conditions aren't very good tonight. It's probably about the worst time to observe the moon, because as you can see, it's very low down in the sky. But we're doing our best. And a very clear seeing condition, you can see a little rill, little gash running down the Alpine Valley. So the geologists say this is a graben. You probably know more about that, Alan. Can you describe what a graben is? I think you're muted, Alan.
You get these things called horsts and grabens, which are the landforms created when you have rift valleys, etc., and various bits either collapse or rise up accordingly. So the grabens are the depressions that are found where basically cracks have appeared in the surface and stuff's fallen down.
Any idea how that particular one formed?
I don't know about that particular one. To be honest, I've no idea what sort of age it is, but I'm guessing it's just been some very, very ancient movement in the lunar surface, possibly as it various lava streams or lava beds were cooling down. Perhaps I really don't know. So I'm just I hesitate the word bee shooting, but
right. So I'm just going across now. I've gone a bit too far. Here you can see this giant impact based in the Mare Imbrium, and you can see these two fairly solitary mountain peaks. This one here is, let me check my grid sheet. This one here is Mount Python and Pico. And they represent, and also there's a little chain of mountains, the Montes Tenerife. The impact that caused the Mare Imbrium, you tend to get a series of concentric rings around the giant impacts. So this represents here, you can see now the Montes Tenerife and this little mountain peak have all were the innermost ring of the Mare Imbrium impact. And the Alps and the Caucasus Mountains running up here would be the second ring in the formation. You can also see these little lines. These are, if you like, sort of solidified larval waves. There are many of them on the moon. Some of them would have formed by shrinkage as the lava cooled, and some of them are actually sort of solid waves. Right, now let's travel south with the clouds going across. So we've got clouds interference. I'm going to turn the gain up a bit where I can increase the brightness to compensate somewhat. This little crater here is a crater called Cassini, named after the Dutch astronomer who discovered the division in Saturn's rings. You can see it's a very old crater. It's been flooded by the Mare Imbrium, so the walls of this crater aren't very high. Here are the Caucasus Mountains, and these three craters here these are all named after various Greek scientific gentry, as it were. Whoops, wrong way. This one is Aristillus, Autolycus, and the big crater here is Archimedes, him of Archimedes' principle. To give you some idea of the scale of these things, Archimedes, let me see, is about 50 miles. This one here is about 50 miles in diameter. As we travel south, we come to this area here, which is Palus Putridinus, the Marsh of Despair. And it was Apollo 15 that landed in this little area at the foot of the Apennine Mountains. You can't see it tonight, but on a decent night, you can make out a little rill. This is called the Hadley Reel. And if you can remember, back to Apollo 15 days, they were driving a little lunar buggy around to the rim of this rill at the foothills of Mount Hadley that sits here. As we make our way down the Apennine Mountains, whoops, wrong way again, we come to a lovely little crater, Aristophanes. Kathleen, I'm live on YouTube at the moment. Okay, here's Fiona. Sorry about that. That was Kathleen. Right, Aristophanes. This sits right on the end of the Apennine Mountains, and that again is named after a Greek astronomer and geographer, and that's about 36 miles in diameter. Looks like we've got some clouds. Going to increase the gain. Whoops, it comes and goes, isn't it? I'm sorry, I've got to adjust the exposure. Yeah, we've got a fair amount of cloud drifting over now. So, Aristophanes. Let's carry on and travel a bit further south. We'll soon come to a wonderful crater chain. Just coming into view now. I'll just center it. So we have the large one here is Ptolemaeus, then Alphonsus and Arzachel. This is probably the most magnificent formation on the moon. And Galileo did a wonderful drawing of this with his newly invented telescope. Go full screen. Other craters, large craters here. This is Albertigenius. And there's a little crater Davy. And along here, you can't probably see it, but there's a little chain of craters. This is called a catena or a crater chain. Probably formed by a broken up comet, rather like the comet that hit Jupiter SL9 in 1995. The Davy crater chain would have formed a similar manner by like a strafing of the little asteroid or comet that is broken up, and they all impacting in a straight line. Now, just to the right of, I might have gone past it. Let's go back again. Yeah, we can see it now. There's a very curious feature here, that like a dark hair grip. Oops, we're slewing off. I'm just pulling you back. This feature is called the Great Wall. It's probably a fault in the lunar surface, but although it looks impressive, it's only a matter of probably 50 meters high. When the sun is shining from the other direction, it appears, illuminates it, and it appears as a bright gash in the moon. Well, it looks like we're coming back again. We might be coming back. I'm just going to pop outside and see how thick the cloud is. Be back in a sec.
Hi, Mike. How's it looking where you are?
Some very high cloud, but it's just about visible. You can just about make out the details and so on.
Yeah.
But not good.
No, it's not good where I am.
We have a very brief gap in the clouds at the moment, so I'll carry on. Oops, turn the gain down a bit. Let's carry on traveling south. A bit too bright now. So now we've reached the southern limb of the moon. The craters we can see here is, unfortunately, the very impressive crater Tycho is still in shadow, but we've got crater Mauritius here, I believe, and the giant crater Clavius is still in shadow. It will when the sunlight hits the crater floor, probably in a few more hours' time. If we slowly glide back over the moon, because I don't think we've got it for much longer. Of course, the moon is a pretty tiny world. It's only about 2,000 miles in diameter, a quarter of the size of the Earth. Crater Aristophanes again. Well, it looks as though we're going to lose it. And I think it looks like there's fairly 10-10 cloud cover. So that's a bit of an introduction to the moon. I'm going to stop sharing now and perhaps hand you over to Alan. I think you're muted, Alan.
No.
Okay.
Yeah, I had the Zoom session minimized. I'm watching it simultaneously on the YouTube channel, or it's not quite simultaneous because there's a lag of about anywhere between 10 and 25 seconds or something.
I think that was what's causing a problem last night, because
that was certainly where the echoes were.
Soundtrack was coming back.
Yeah. Okay. Well, I had rather hoped to be able to demonstrate what's called afocal imaging this evening. A lot of people, when they first have a telescope, even if they haven't got any of the sort of sophisticated cameras of the sort we've been talking about over the last couple of evenings, they have a distinct urge to shove a camera up against their eyepiece and see if they can manage to take a shot. I mean, I certainly did that with a little pocket camera early on, and most people have tried doing the same. More recently, of course, the last few years, it's mobile phone cameras, smartphones, which have very much taken over as the introductory thing, which can provide interesting results and can provide some quite good results. The biggest problem with trying to do afocal imaging, I shan't even bother to try and start explaining why it's called afocal, but through the eyepiece with a phone, is trying to hold your hand steady. And that's remarkably difficult to achieve. Now, for that reason, there have been a number of devices created over the years. The first time I created stuff was using plastic plumbing parts, which had certain effects. And I've built up a collection of different devices for doing it, culminating in this wonderful contraption that I'm holding here. Now, this is made by the firm called Celestron, who make a very respectable range of telescopes. And what this one does, they call it most of the Celestron devices have the word NEX in the front in many cases. So this is an XYZ mobile phone holder. So you can see my smartphone is clamped into this thing. Then it has, this is just a normal telescope eyepiece fastened in here, and it's clamped down. You can tighten the fastening, and then you have adjustment screws. I'm trying to get the angle right so I can see what I'm pointing at. Adjustments for going up and down and sideways, and there's another adjustment here for moving in and out a little bit. I sometimes find actually it could do with something like a rubber band just to overcome the slight issues of flex in there. So what you do is basically you get your telescope focused visually, then take the eyepiece out. What I was using was exactly the same kind of eyepiece earlier on, and getting that focused, and then the idea being to pop this in, tighten it up, and off you go, which would have been very nice, except that it went totally cloudy and I just can't see anything at all through it. I couldn't even see anything visually. But doing afocal imaging, you can get some quite good results. Anybody who looks, say, at Sky at Night magazine will regularly see stuff that's been, people have done there that's of pretty high standard. Unfortunately, even visually, I couldn't get through to see anything. Ideally, if you have a smartphone, you should hunt around and try and find some of the perhaps the hidden extras about the camera. I'd had my smartphone for a few years before I started actually exploring these, and it gives you the ability to do slightly longer exposures, to increase the ISO rating, and various things like that you will only find if you've got a full-scale proper camera on. You can also use DSLR cameras on brackets, but it's usually better to have a very special attachment which lets your DSLR hook into the camera, into the telescope directly. I think, Mike, you use DSLR quite often.
Yes. Just one point, actually. I found a very good app on the Android phone. It's called the Camera FV5, and it allows you to control just about everything: exposure, settings up to about 1600 ISO and all sorts.
Yeah.
So I find that's very useful.
It's controlling your Canon, is it?
Sorry?
You're using that to control your Canon?
No, no. This is just for a focal type
Oh, right, okay.
work. I don't know whether you can see.
Oh,
There's
yeah.
a little. I'll hold it a bit closer. Can you see that?
Yeah.
That's a little module I bought a couple of years back.
Yeah.
Holds a mobile phone and just clamps onto an existing eyepiece, and it works extremely well.
Okay, so
I think the technology of these mobile phones is so great now. Someone showed me a picture, a handheld shot of the Orion Nebula taken with an iPhone. He'd done a video and he'd stacked the sequence and aligned it, and it was as good as a tracked image. It was amazing.
I think the light sensitivity to a lot of smartphones is very, very good. I was in a National Trust house just the other day, and of course they keep the light levels very low so that it doesn't make the colors fade on fabric. So I held up my smartphone, not using a flash or anything. I just held up my smartphone and looked through it, and I could actually see much more detail than with the naked eye, just through the viewfinder of the smartphone. So yeah, they're pretty. Mine's quite an old one now. Yeah. I think it's not even supported by Samsung anymore. I'm going to be forced to change it at some stage in the next year or two. And yeah, so afocal imaging, worth trying, but as you've seen from Mike and myself, well worth thinking about. They're not expensive. I mean, this one I'm waving here, I think it's only about 60 quid or something like that.
I think
this one was about 25.
Yeah.
Yep. Certainly a good way to start if you're wanting to start astronomy, is start trying to get images from your telescope with your iPhone, because you can have a remarkably successful from, children come to the NLO and say, well, can I take a picture from their smartphone? Invariably, they succeed and they're really impressed.
Yeah. Yeah, something like the moon is a really good target to try for your first go at this kind of thing.
Right, thanks, Alan.
I've still got not too much cloud. If you want to have a quick look.
Yeah, please go ahead.
Okay, let me just hang on.
I'm here at the moment.
Share screen. Right. That should. Right. Can you see that?
Yeah, well done. Yes, lovely. The whole moon.
Yep. I'm still using the little clockwork mount because I still can't manage to get the main scope out at the moment. But this is using a very old 4-inch reflector. It's a Schmidt-Cassegrain reflector with my DSLR on the back of it. Everything is very precarious and held down with a large weight to stop things falling over. But yeah, it's not tracking very well because I've got there's too much cloud to see the pole star, so I've not been able to polar align it properly. So it's been a bit of guesswork, but it's still tracking reasonably well.
I should explain that's the moon the right way up. Of course, with my image, we were seeing the moon upside down, but if you go outside now, that will be the way the moon is.
That's what you actually see. Yeah, yeah. Now, obviously, I can't do anything except just take the occasional shot. But let's just see how it's.
And I can see the crater Plato, the dark crater near the top, just at the top of the Mare Imbrium. And you can see.
There's a bit more cloud coming across now. Yeah.
Yeah, you can see all the dark seas there.
Yeah.
Sea of Tranquility, Sea of Serenity.
Oh, hang on. Should be. I had an interesting shot a little bit earlier on with a vapor trail that went right across the moon.
I caught a bird flying across the moon the other night.
Yeah, no, I think the cloud's beginning to build up again. Yeah.
Great. Well, thanks very much, Mike.
Anyway, I will switch that back for you.
Yeah. Okay, what I'll do now is I will, whoops. Can you all see that?
Yep.
This is a telescope that I was using to image the moon just now. It's gone completely cloudy. There's no signal at all. So it is a 9-inch Schmidt-Cassegrain. So you have a spherical mirror at the bottom here, another little mirror at the top, and the light bounces back down the tube to the camera here. This is a color camera. Alongside it, we've got a little secondary telescope. This is called the guide telescope. There's another little camera linked to that. And both the cameras are linked to this little cigarette-shaped box. This is called an ASI Air Pro, little Raspberry Pi computer that will control this telescope. So it does all the imaging. There's a little memory card that sits in the back here. It will control it. This is the equatorial mount. It will control where the telescope points to. It will collect the images. And all this is linked to a little iPad here, which I use to control the telescope. So it works remarkably well. And we'll just go through a few pictures that I took a few nights ago. And that was the moon last night. We mentioned the Great Alpine Valley. Well, now, of course, the sun has risen well over it. And the crater Plato, which was in darkness, in shadow last night, would appear around about here. This was a few nights ago when the moon was setting fairly early on in the evening. The moon has now moved to this position between Jupiter and Saturn. It's about as low first quarter moon as you can get. So really it's not the best time to be observing the moon. I don't know why they chose this week as International Observe the Moon Night. So it lies in the crater Capricornus here. This is Aquarius. The bright star up above is Altair in the Eagle and the Milky Way, although probably the moon's too bright for us to see the Milky Way. The Milky Way will be running up from the southwestern horizon. Unfortunately, we can't show you Jupiter night. We've had a few successes at Jupiter for the last few nights. The first night we saw the Great Red Spot, and this is on the 12th. It was just appearing on the limb of Jupiter, and we followed it. This is about 45 minutes later, crossing what we call the central meridian, the zero line of longitude of Jupiter. Of course, Jupiter is a gas giant, 88,000 miles in diameter. You get 10 Earths strung across the diameter of Jupiter. And this picture was last night's picture. We can see little white ovals in the south temperate belt up here. Lots of storms on Jupiter, and a lot of these we call the dark areas belts and the light areas zones. And Jupiter rotates very quickly in just about 9 hours 50 minutes, and you get a lot of turbulence and eddies forming on these counter-rotating currents. And you get, certainly, each night you observe Jupiter, you see different features. Occasionally, you might see a little shadow transit. This is the shadow of the moon Europa. There's Europa just about to come off the limb of the planet. Sun's in this direction, casting a shadow on the planet. But of course, this isn't a solid planet. This is all gaseous. Jupiter is a gas giant. Those are the tops of clouds. We also saw Saturn a few nights ago. I had very good seeing conditions. This is a still atmosphere allowing us to pick up a fair amount of detail. Here is, I was telling you about the crater Cassini on the moon. He's famous because he discovered this ring, this dark ring in planets, Saturn's rings, which is hereafter known as the Cassini division. And that was a picture we took last night. Not quite so clear, but we got the rings. Oh, that was last night. Yeah, that was the night before. So you can see the seeing conditions improved a little bit last night. We also saw the blue planet Neptune and its moon Triton. Of course, Neptune is another gas giant. It appears as a greeny blue in the telescope. And we also saw some deep sky objects. This is a great Pegasus globular star cluster, about 33,000 light years distant. And although that was a stacked image of 10 30-second exposures, I did a longer sequence. And this shows all the little blue, lovely blue RR Lyrae stars. These are variable stars that have very short periods, about 4 or 5 hours. These are very old structures, about 12 billion years old. We also went out and saw the dear-lit galaxy, NGC 7331, a fine galaxy in Pegasus. And again, that was a live stack of just 10 30-second exposures. And after the live stream meeting, I took a picture of the famous Crab Nebula at Supernova Remnant. And this is the star that the Chinese saw explode in 1064. And this little lower star of the pair here is the pulsar, the neutron star, that's rotating about 30 times a second and causing this material gaseous cloud to glow. What else is happening in the sky? Well, we have a little comet that's outbursting. This is a very unusual comet. It orbits well out beyond the orbit of Jupiter in a fairly circular orbit. So it doesn't come near the sun. Now, when a comet comes near the sun warms it up. If it comes between, obviously, Mars and the Earth, where water can exist in the liquid state, these comets sublimate and a tail will form. When a comet is way out beyond Jupiter, there's not enough energy to sublimate the water content. So it's unusual to get a coma. So what we don't understand is what's causing this comet to outburst. It's had 4 brightenings over the last 4 or 5 days. So something of perhaps internal structure has collapsed and formed this cloud or coma around the nucleus of the comet. The nucleus of the comet are always generally very tiny, probably not more than a few miles in diameter. But the gas cloud, the coma, can be many hundreds of thousands of miles in diameter if it's outbursting. There was a famous comet Holmes a few years ago that expanded probably about to the size of Jupiter, even more so. There were some internal structures that caused this to expand. And that was a picture taken last night. Going further out into space, we have more galaxies. This is an edge-on galaxy in Andromeda, NGC 891. well placed in the sky at the moment. You can see why Patrick Moore described a galaxy as two fried eggs laid back to back. You have the central part here is a nucleus of the galaxy. Then you have the flattened disk. And you can also see dark obscuring matter. And this will give rise to new stars. Sun is waking up. We've had a nice little sunspot. This was a few days ago. That sunspot would have moved round now. This was called Sunspot Active Region 2882. And it did cause a coronal mass ejection, and there were aurora seen in northern latitudes over the last few nights from material thrown off the sun by this little active sunspot. And of course, if you get when all this material reaches the Earth, the particles get drawn into the Earth's magnetic north and south pole, and they ionize the atmosphere, and you get this wonderful greenish glow. So I'm going to stop sharing there now. I did actually have the moon back. We can probably switch back. Back to the moon. I'll increase exposure. Rather hazy moon. I'm afraid it's gone again. I don't think it's worth us trying for any of the planets because we won't see much. No, 3 clear nights in a row is too much to expect. Right, Alan or Mike, do you want to show anything else?
Yes, I can do, David. A lot of the images that you've been showing us are wonderful coloured images because you've got the colour camera, so they're showing sort of the real colour of what you can see through the telescope. What we often get asked is, what would, if you're flying around in a spaceship, what would all these nebula actually look like? Would there be these wonderful colors? People see the pictures from things like the Hubble telescope and think, oh gosh, it's going to be fantastically colorful out in space. Well, sadly, no. If Captain Kirk was zooming past some of these things, he would just be looking at fairly grayish sort of clouds, perhaps with a hint of color, because the intensity is just not great enough to register on the eye. However, with color cameras like the ones that David's got, that can intensify the color, and you get these very nice images. Now, the one that's over David's shoulder there, I've no idea if that was taken with a color camera or by another method, which is one we very commonly use, is we use monochrome cameras. In other words, the image is just in shades of gray, many more than 50. And we use different filters. Now, the simplest set of filters is red, green, and blue. And you take an image or a set of images in red and stack those, a set of images in green, stack those, set of images in blue and stack those, and then put them together to get a composite color image. Another very common thing that we do in astronomy is to use what are called narrowband filters. Narrowband filters. These look just at a very narrow band of the spectrum of light. In fact, professional astronomers, nearly all the work they do is narrowband work, because then they're discovering all such things about the constituent materials of gas clouds, etc., from this. So as amateur astronomers, we often make do with this. And if I just share my screen and pick up on, yeah, that one. Bring it up. Okay. Yeah. Okay. Hopefully what you can see there is a picture of what's called the Eagle Nebula. Is that one showing up okay?
Yeah, that's fine. Yeah.
Yeah. One of the most famous Hubble telescope images is this central section here called the Pillars of Creation, but the whole thing is called the Eagle Nebula. Now, this image I took using a series of shots through what's called a hydrogen alpha filter, and that captures in the band, what is it, 656 nanometers, tiny portion of the spectrum. If I move on to another image, this one is fly going around my head. You can see it looks quite different. Now, this one is using a different part of the spectrum. It's called oxygen 3, triply ionized oxygen, and that comes in at about 501 nanometers, more down towards the blue-green end. I should have said that the hydrogen alpha is in the reddish part of the spectrum. Here we're just on the border between blue and green. And then if we go to the third commonly used filter, this one is sulfur 2, which is 672 nanometers, which is not that much far above the 656 of hydrogen alpha. But these are a very common set of filters. The other one, there's a hydrogen beta filter, which is quite often used as well. So what we can do with these, catch that fly that's buzzing around my head, is to amalgamate these into an image. If I just go back up through there. Okay, now there's a colored image using a particular method in which the sulfur 2 is mapped onto red, hydrogen alpha is mapped onto green, and oxygen 3 is mapped onto blue. Now this is actually called the Hubble Palette. When the Hubble telescope took its wonderful pictures of the Pillars of Creation, I think it actually used about 7 different filters. We amateurs make do with a smaller selection and finish up with that. Now you will notice there's a rather strange phenomenon, and the stars tend to have a slightly mauve look about them, which you know, you can mess about and change that. But what we're interested in is something that sort of looks rather nice. Now, what other ways could we use these palettes, these different sets of colors? Here we've got exactly the same set of images, the 3 images, but with these ones I've mapped the sulfur, I should say, onto blue, the hydrogen alpha onto red, which is closer to what it would normally be, and the oxygen 3 is onto green. And it gives a very different appearance. Let's just flick back. There's that one, and flicking over to this one, you can see how things change. If you look at the central area, quite a few changes are very obvious there. So basically, beauty is in the eye of the beholder. I mean, as amateur astronomers, we're not trying to accomplish scientific achievements here. We're trying to get pictures that we think look nice, basically. So that's the satisfying part of our hobby. Now, one of the other interesting things is that, which I don't think I've got, no, I didn't take an image of. Sometimes if time is short, you don't bother taking more than 2 filters. So for example, if you're using RGB filters, you could just make do with red and blue. And if you're working in Hubble Palette, you could just make do with a couple of these. And then there are various techniques for synthesizing another color from those two by using components of the color in different proportions. So most commonly, you would use red and blue filter and then synthesize green to give you your RGB image. It's a good idea always to leave your green till the last if you're imaging in monochrome, because then if the conditions change, you'll have something you can synthesize with it. So there's lots and lots of tricks and so on to how we deal with those, and various either dedicated programs or Photoshop or the new kid on the block Affinity Photo, which is very, very good for astronomy. All of these things are very useful, but bear in mind that what you see is an artifact of the way we've chosen to set it up. Unless we're actually using a proper color camera like David's been showing us, many of us are really just making it up as we go along. Okay, I'll stop sharing and hand you back. Here we go.
Thank you, Alan. Beautiful images of the Eagle Nebula there. Okay, folks. Time's getting on. I'm afraid it's gone completely cloudy here. I haven't got anything on my viewing through the telescope at the moment. Is there anything else you would like to add, Mike?
No, I think Alan's covered it very nicely, actually. One thing I use though with the DSLR, because it is a color camera, is I use a quad band filter, and basically this is it takes hydrogen alpha, hydrogen beta, O3 and sulfur, and it's only sensitive in those particular areas, and that actually gives very good results for nebulae, because there's a lot of O2 and sulfur in or O3 and sulfur in nebulae. But I also have another filter which is called a city light suppression filter, because I'm in the middle of a town here. I get quite a lot of light pollution, and I find that one it's not as tight and sharp as the quad band, but it is very good for looking at galaxies and star clusters. So anyway, that's really all I needed to add.
Great.
This is the filter that I would have been using tonight. It's an astronomic CLS filter, which ideally would cut down on some of the sodium. Because all these new LED lights, they produce in a different band, but certainly for the old sodium lights, some of these filters are quite useful.
Yeah, the new LED ones are very difficult to guard against now, unfortunately. Yeah.
So, folks, Alan and Mike, thank you very much for this evening. I'm sorry the clouds defeated us tonight, but we did have 2 clear nights, last night and the night before.
Certainly YouTube's been working well the whole way through, because I've got it in a corner of my screen.
So good night all, and thanks for looking in.
Okay, thanks a lot, David.